2.2a, direct variation. Direct variation is talking about some kind of relationship between x and y. So when you see it as an equation, it's going to look like this: y equals kx. Any equation that has that form has a direct relationship. But what does that mean? Look at number 1. If you look at the numbers, you can kind of think of it as 2 times 7 equals 14, 3 times 7 equals 21, and 5 times 7 equals 35. The relationship is the same. It's a direct relationship because it's times 7 times 7 times 7. All right, so it's going to have that form, y equals kx, but specifically k is 7. That's the multiplier. So when it says find the constant of variation, that's k equals 7. That's your constant of variation. And write the function rule. Write the function rule means plug it back into this equation. So y equals 7x. We've got a constant of variation and a function rule. If you look at number 3, 11 times 2 is 22, and 16 times 2 is 32. But 7 times 6 is 42. So since that relationship isn't the same, this is not direct variation. Now, let's go back to problem number 1 again. I want to show you what happens if the relationship's reversed. So let's just say the numbers are 14 and 2, 21 and 3, 35 and 5. So I just switched the numbers around. So this time it's the numbers are getting smaller from x to y. So it's backwards. You would think about it as divide by 7 and divide by 7 and divide by 7, and it still has that relationship, but this time it's divide by 7 instead of multiplied times 7. And so in this case, that constant, if you divide by 7, you should think about that as a fraction. We can still think about it as multiplication if we write it as a fraction, and so that constant would be 1/7, and the function rule would be y equals 1/7 x. So I look at it as basically, if it's getting bigger, it's going to be multiplied, and if it's getting smaller, it's going to be divided. That's kind of a way you can tell. Number 5, determine whether y varies directly with x. All you have to do is look for this form. If it's in that form, or if it can be written in that form, then it's direct. And so this one's perfect. It's set up in that form. Y equals kx, this number would be k equals 12. This one, same thing. Yeah, it's good. It's right. It's a direct variation. K equals -2. This one's different. It's not in that form. Number 9 is not in that form because you've got that extra -3. This is not direct variation. If we look at number 11, 11 looks weird, and your gut feeling is it's not direct variation, but really you should get y by itself. So let's isolate the y. I'm going to do that by adding 6x to both sides. I'm just trying to get y by itself. So if I add 6x to both sides, I'm going to get y equals 6x. And sure enough, that looks like what I need it to look like. That's direct variation with k equal to 6. So I want to give you another example of that real quick. If the problem had said this, y minus 6x equals 2, and you try to do the same thing, if you add 6x to both sides, notice those aren't like terms. You'd get y equals 6x plus 2. That's not in the right form because you've got that extra plus 2. That's not direct variation. Number 13, find the value of the variable if y varies directly with x. So they're telling us that y varies directly with x. So that's good. And, I guess that means that y equals kx. But I'm going to give you a different way of doing this problem that I think is easier. Okay? If y varies directly with x, then what's going to happen is you can set up a proportion. And if it's a direct variation, then y equals x should imply y equals x. And so I know that seems silly to write that down. Y equals x equals y equals x. But later, when it's not direct variation, we do a different one, then it's going to be a different relationship, and it'd be a different proportion. So for now, just remember, if it's direct variation, you've got kind of this thing happening. Y equals x equals y equals x. So I'm going to set up a proportion. That means fraction equals fraction. And I'm going to keep it in that form. So I've got y and x. So I'm going to say y number over x number equals, and then I've got to keep the same exact relationship. That's what makes it direct. Y over x. So notice my y number is 6. That's going to go on the top. And my x number is my unknown, so I'll just leave that as an x. So notice I set it up as y over x equals y over x. And then I'm going to solve that proportion. Hopefully you remember cross multiplication. I think that's the fastest way to solve proportions. 4 times x, 4x, equals negative 2 times 6 is negative 12. So we've got that simple equation, and we're going to ISO the variable. So to get the x by itself, I see times 4, so we're going to divide both sides by 4. X equals negative 3. There are other ways to do this problem, but I think this is probably the easiest way to do this problem. Number 15, same thing. Just make sure you keep the same relationship. If you say y over x, 7 over 2, then you've got to say y over x on the other side. Y over x equals y over x. I cross multiply, and I get 7x equals 2 times 3 is 6. And this one feels weird because it's not going to come out even, but that's okay. Just keep doing the same thing. If you want to ISO the x, you're going to have to divide by 7. That cancels out the 7. And it gives you a fraction, but so what? Big deal. Deal with it. We've got a fraction. X equals 6 over 7. $17. Same thing. Direct variation, so y over x equals y over x. Notice this time the y is the unknown, and that's okay. Just make sure you keep doing y over x equals y over x. When I cross multiply, I like to do the one with the variable first. Doesn't really matter. But negative 3 times y is negative 3y. And negative 7 times 9. Do you need a calculator for that? It's negative 63. To ISO this variable, we're going to divide by negative 3. So divide by negative 3. Y equals 21. $19, for a given speed, the distance traveled varies directly with time. So that's kind of important because they're telling you it's got that same relationship. Y equals kx. Or if you want to do the proportion, y over x equals y over x. Kate's school is 5 miles away from her home, and it takes her 10 minutes to reach the school. Okay, now, this is a story problem, and I think it's a little bit harder to see the y and the x, so maybe we shouldn't use y and x at all. Maybe we should use what they give me, distance and time. So maybe I would say d equals kt. It's the same thing. I just used different letters. I think it's a little bit easier now to see what to do. Okay, I'm going to say d over t equals d over t. Keep that proportion, keep that relationship, and you should be good. So this problem is really the same as the others. We've got Kate's school is 5 miles away from home, and it takes her 10 minutes. So distance over time. We just have to make sure we keep that relationship the same thing, distance over time. If Josh lives 2 miles from school, well, that's a distance, so that's going to go on the top, and travels at the same speed as Kate, how long will it take him to reach? Well, that's time. So there's my setup. D over t equals d over t, and I'm still going to solve it the same way. I'm going to cross multiply. 5 times t equals 2 times 10 is 20. So the t, I'm going to divide by 5. That gives me t equals 4. What are we talking about here? Time, how long? It's talking about minutes, so 4 minutes.